Hello and welcome to Get to Speed with AI. In this segment and many more videos that are coming, we're going to build AI models and then explain what those models are doing. And these are going to be real life models. So for today, we're going to start with a problem that we want to solve with AI by building a deep learning model. And this problem is to predict fuel efficiency. We'll be given a data set from the University of California, and the data set will have some information regarding the car, and then we'll be required to predict its miles per gallon. So and how are we going to do that? So we're going to use FastAI library, and I've shared here some information about FastAI. You can see first the book. The FastAI has a book, a free book available online, but it also has released a course, the version number 4 of the course that they release every year. It's an amazing course. I would encourage everyone who has time to go to this course.fastai.ai, and then the course will be hosted there. The book also has its printed version, and it could be purchased directly on Amazon. So yeah, I would encourage you also buying the book, because it's amazing when you practice while at the same time reading from the book. I will be also using another book which is also freely available online, and this is the Dive into Deep Learning, and the book can be found on that URL. It's an amazing book itself. It has a lot of maths, but it's still a very good book for people who are interested to understand what's happening under the hood into the machine learning models. All right, so to be able to follow this video, you need to have a little bit of Python. So you have to understand a little bit of Python. We're also going to be using pandas during the data manipulation and analysis. And so, yeah, having the understanding of how data frames work, that will be good. But we may also touch a little bit of maths, because it's inevitable that we talk about artificial intelligence without talking about maths. But this is not a course about maths. And even though you may require to have that maths, it's not really a requirement that can stop you from following. So don't feel like if you don't have any maths background that you are not able to follow. You are really welcome to follow this video, and I can assure you that you're still able to do everything that we'll show. So this is the way we want to, this is the approach we want to use during this video and other videos. So we'll always start by building a model, a state-of-the-art model. And then after we build the model and running, we'll deep dive into the model and try to understand how it works and what's happening under the hood. And then we expect that you will, after you've learned all this, you will do it by yourself, and this is the best way to learn anything. So without any further delay, let's build our first model. All right, so I've got here our first model that we're going to build. I've already written the model. I'm going to take you through the different parts of the model. It's a regression model, and we'll be using FastAI library. Its recent version is version 2, and we'll start from there. So to do that, I'll be running all the codes on Google Colab. So Google Colab is a free product. I will provide the URL in the description that explains a little bit of Google Colab, but it provides free GPU. So you can see here, if I look in the runtime, I've got a GPU, which is just for free. All right. So everything here will be, I'll post also these notebooks so that you can play with them by yourself. All right. So let's start. The first thing we do, we start by installing FastAI library number 2, the version number 2. By doing pip install FastAI 2. The exclamation point here is a way of running terminal command through through Python notebooks. All right, so then after that, the installation is done. So it will print a bunch of information here during the installation. I've cleared them out so that we get some space. So after the installation is done, we start by importing FastAI library. The dataset that we're going to deal with is a tabular dataset. So the tabular dataset is, like the normal dataset where you have information organized into columns and rows. That's the most common, versus the dataset where you have things like video, images, and so on. So this one is a tabular. And we going to download this dataset from the archives of the University of California, as it's seen here. And then we're going to use this download data. This is a function that was developed by FastAI. And what it does, you provide the URL, it will download the dataset from this URL, and then we'll just put it on the server. And in this case, we'll return also a path which tells where the dataset is. All right. So the dataset has different columns, but we've got some of you that we're interested in. So we are interested in the MPG, cylinders, displacement, horsepower, weight, and all these columns. And then we also have we then load our data set from the path by we load it into a data frame in pandas data frame by using the read CSV, which will read the CSV file that was previously downloaded here, and then we pass it the column names that we are interested in, and it will do that. And this is the data set. This is the last 5 rows of the data set, and you can see the information out here. Okay, so now before we can proceed to building the model, we want to make sure that our data set is ready. One of the common things to do during the cleaning of data, we want to check if there are some missing data, and we do that by doing dataset is.sum. So this will show all how many cells that are missing data. In this case, we have the majority of them, almost all of them have nothing missing, but the horsepower has actually 6 missing cells. So this is our 6 cells that are missing information. So so what we'll do, you have to decide what to do with this information, but at this point we're not going to do anything. FastAI library will take care of this. We'll replace this missing dataset, or we'll see later into this notebook how that's done. All right, so another thing we're going to do, if you observe here the origin, there is a column named origin. So the origin column it has the information about the origin of the car, or where the car was made. So the country of origin. In this case, we have 1, 2, and 3 countries, and those are cars made in US, Europe, and Japan only. So this is the cars that we have in this data set. And so we want to make this information clear. So to do that, I want to replace so this is a step that I could have skipped, and it wouldn't affect anything, but for the clarity of what we're doing, I'm going to replace those numbers with the actual country name. So to do that, I will map those ID to the actual country, and then print the last 5 lines. As we can see now, we have in the origin US, Europe, and USA. All right. So after that, we may be interested into knowing how many laws do we have into our data set. We want to know the shape of our data set, and in pandas you get that by just calling the function the object shape. So the object shape will return a tuple with with number of rows. The first element of the tuple is number of rows. The second element is number of columns. So we have 398 examples in this data set and 8 rows. Okay, and then we may also be interested to get some statistics about the data. So on the statistics side, things that we usually want to see, we're interested to see what's the minimum, what's the maximum, and this will let you know, and also the standard deviations, which will let you know how spread the data set, the distribution of your data set is. So in this case, we'll be interested mostly at looking this information. For example, we can see that the model year is between, the minimum is 70, so this is a car made in the 70s, and the maximum is 82. So the sum, this is tell us this data set has information about cars that were made between 70s and the 80s, early 80s. And we can also see other information like acceleration, which has a minimum of 8 and a maximum of 24. Okay, and so on. So you can look at all this, but the common thing that we can immediately see here is that all these data are not on the same scale. Okay, so for instance, if you have this one at minimum being 4 and being 3 and the maximum being 8, that's different from having, for instance, the weight of the car, which is in thousands. Okay, the minimum being 1,613 and the maximum being 5,140. All right, so we'll have to do something about this difference into how these data scale. All right, so after we've seen these statistics, we also want to see if there is any sort of relationship between our target, our label. In this case, one thing I forgot to mention, like we've seen into the introduction, we want to predict the fuel efficiency of these cars. And that information is actually the MPG, so the mile per gallon. This is our target. This is our label that we want to predict. All right, so to do that, we want to see if there is some obvious relationship between our target A, which is MPG, versus any of a few of these columns that we can choose, and see if there is anything intuitive. So I've chosen 3 columns: the weight, the horsepower, and the model year of the car. All right, so now I'm going to print this side by side, and we can see here that when we do weight versus MPG, there is clearly a relationship. As you can see, for the heavier the car is, the heavier the car is, the worse it is going to be in terms of MPG. So we can see here that the more as the weight increases, the MPG will decrease, which means the heavier car will be using a lot of fuel. And we see the same situation with the horsepower. The more the car is powerful, the more it's going to consume a lot of fuel per mile. But when we go to the model year, we can see that there is also some sort of relationship that we can see. We can see there is a little bit of increase in MPG by year, which means the technology of the car was improving and they were becoming more efficient into the way they measure into the way they make cars that consume less. But given that there is just between 70 and 82, just a space of 10 years, so I wouldn't think there is that much improvement. That's why we see a lot of spread of data, but a careful observation can still see that there is something there. All right, so we know this information, and this gives us some sort of confidence that this data actually behaves very well, that we can model it without a problem. Okay, so let's now build the model. So we'll build the model quickly. I'm not going to explain this straight away, but we'll then, once we've built the model, we'll see what we've done. So one of the things we'll do, we'll just build the model. This is how this DLS will be our data. So we want to build the model. But one thing I can mention, when we build the model, we have choices of whether we want to expose all the data at a time to the model, or whether we want to expose data by batch of data. So the common thing is you don't want the data to be provided to the model at the same time, because if you have millions of data, then it's not going to fit into your memory, and also you're going to have problem with computation, the calculations that the model will going to do. So the thing that everyone does is you want to provide a batch size, and then on the model will see that's amount of data at a time until it has made a complete loop through the data. So in this case, we'll be providing 64 data at a time, and then we call the tabular learner, which is a class provided by FastAI, which is this is the model, the class that provide the access to the model architecture of whatever we want to build as a model. So in this case, because we're dealing with tabular data, then we'll have to build a tabular model, and we'll call tabular learner, which we pass the data and we tell it how many layers we want. This is about deep neural networks, so we'll need to tell how many layers we want. In this case, we're saying let's have the first layer with 64, and another layer with 32, and then another layer with 1 output. And then we also precise loss function and metrics, and we call the method fit one cycle with 20. This 20 is how many times we want to look into the data, and then we run, and our model is now running. We can see that the validation loss is decreasing with each time it runs, and by the end of our 20 epochs, we've already got to 7.9 from 600. So that's a good model. It has reduced the error, and to prove that the error has been reducing, we can plot the loss plot, which will show how the loss has reduced with time. So that's also out the box provided by the FastAI library under an object called recorder, which keeps some information about what the model is doing. In this case, we're interested in the plot loss, and we have it. We can see in blue that the trend validation went down with time. It was still going down if we had provided enough epochs for training. But the interesting thing is this orange, which also shows that the validation set went down and then it plateaued, which shows that it was no longer improving because it has reached the maximum it could get. Like it's perfect at this point. That's the perfect it could get. So, and then the other thing we might be interested in, so we've already trained our model. We've seen that it has behaved very well by reducing the loss. We are now interested into predicting values, providing this model some information, and then we'll predict, and then we'll compare the prediction with the true values to see how well we did. So we could do that in a graph as well. So the way we do, we'll call this getPreds. So the getPreds will return prediction for the validation set. We haven't talked about the validation set, but we'll see. So this is the validation set is a split data that was put aside, and then automatically this model will feed that data to the model, and then return the information about what it predicted and what's the actual value. And then we can take the error, which is just the difference between what we predicted and what is the actual value, and then we plot that information. And as you can see, we've got the histogram of the error, and it shows that this histogram is slightly almost centered on 0, which shows that there is a big density around 0. In other words, we predicted pretty much, our model is doing a very good job by predicting something close to the actual value, so that the difference is close to 0. And to make that clear, let's add the density plot, and you'll see that it shows a bell-shaped curve and almostly centered in 0. So you want it to be centered in 0, but yeah, given that we have few data, just 300 of them, and we are almost to the 0, this shows this model is actually doing a very good job at estimating these values. Another plot we can do, we can compare directly the data that we have, the truth values versus the predicted one. So the red here shows a perfect model, or in other words, the true values. So as you can see, the true values are aligned in this line, and we want to see how far is our predictions per each prediction. So we can see that there are some data which fell immediately into the red, which shows these were data where we predicted almost perfectly. And then there are slightly other many data around the red, which shows we predicted them not exactly, but close enough to the true values. All right, that's it for video part 1. We've just built a regression model without understanding all its details. In the next video part 2, we'll deep dive into the model that we've just built and try to understand all its building blocks. Also, I've skipped a few details so that the video won't be too big. But in the description, you'll find the URL to the notebook that we've used, and in the notebook there will be a lot of explanation and details. So I hope you read the notebook, you go through the notebook before you can watch video number 2. And if you haven't subscribed, please do so, because I will be posting more of videos, and this way you could get notified. So I hope to see you next, and ciao.